Hello everyone, this is Professor Kuehn. We have been talking about Chapter 19 of A Student's Guide Through the Great Physics texts, where we have been giving some introductory comments on Newton's Principia. So there's been a lot of background information in the last 4 lectures. If you didn't grasp everything, that's okay. I think it's important to sort of get your feet wet in understanding the historical context in which Newton was writing. Let me just remind you of a couple of things. So the idea that was around at least since the time of Aristotle and going up through the time of the Middle Ages up to the time of Descartes is the idea that objects in nature are not strictly made of matter. So that's a very modern view that, for instance, rocks are simply made of matter. The older view is that rocks, plants, animals, people not only are made of matter, but they also have a form, so a substantial form in particular, that sort of animated these and gave them their characteristics. The modern view that was really ushered in by the likes of Descartes rejected this idea of substantial forms. It said these are occult or hidden ideas, hidden quantities. We don't need to appeal to these in order to understand nature, at least most parts of nature. People, well, you still need something strange to understand these thinking things like people. But beyond people, when you're talking about animals or plants or rocks, there's no need to appeal to anything except these material causes. So we can treat most of nature like a machine. We're given a mechanical picture of these natural things. So when Newton begins his Principia in his author's preface in chapter 19, he explains a little bit of the context in which he's writing. He says, well, the moderns really reject this idea of substantial forms of these occult or hidden quantities. And for that matter, the ancients, at least in some respects, treated nature like a machine or a mechanical object. So now what Newton is going to do, he's going to ask, he says, how far can we really go with this mechanical or machine-like picture of nature? So he is thinking about nature as a machine, and he's interested in studying nature, but he's particularly interested in certain features of nature, not the kind of machines that man makes, like bicycles or boats and things like that, but rather the kind of machines that God has made, the perfect artificer. So again, his idea is to study and explore not what man can do, but what God, the perfect artificer or the perfect artist, has done. So he is essentially treating all of nature as if it is an artifact, as a machine, but one with perfect accuracy. So that's essentially what he's trying to do. Now, what is his procedure that he's going to use? His procedure is really threefold. So what he's going to be doing is he says what you have to do is you first have to observe the phenomena of nature. So example, you can watch what's going on in nature. For example, he's going to look at the motion of the planets or look at the motion of falling objects like an apple falling from a tree. That's the first thing you do. Then, by investigating the motion of these objects, one can hypothesize the kind of forces that exist in nature that would produce that kind of motion. Okay, so what kind of laws would one have to postulate in order to produce the kind of motions that we see? So we have now these general laws of nature that he is going to develop. So, for example, his most famous one is the Universal Law of Gravitation. And then, from these laws of nature, then deduce, this is the third step, deduce what other kinds of phenomena might result from these sorts of laws of nature. So for example, if there is a force of gravity acting not just between the sun and the earth, but between the earth and the moon, then what kind of motion would we expect to see tomorrow or in 30 years or 100 years from now with these interacting objects? Was Newton's theory successful? Well, most of the subsequent approaches to the study of moving objects or mechanics really rely on Newton's laws of motion for the next 200 years. And one of the early successes of Newton's approach to the study of nature, his mathematical study of natural philosophy, is the work of Edmund Haley. So Edmund Haley, you might have heard of Halley's Comet. So in 1705, Edmund Haley predicted the return of a comet in 1758, and he used Newton's law of gravity in order to make that kind of prediction. So to be sure, this comet had already been observed for every 74 to 79 years for centuries. Most recently at this time, it was observed by a man named Appianus in 1531. It was observed by Kepler in 1607, and it was observed by Edmund Haley and Flamsteed in 1682. So, but now what Newton provided was a mathematical procedure for using his law of gravity to predict the time of return of this comet. So it was predicted to return in 1758, and it returned right around there, but actually within a couple of years of that. So it wasn't a perfectly good prediction. In any case, the return of Halley's Comet was seen as a triumph for Newton's theory of gravity. Did Newton's work find the limit to the mechanical view of nature? So here is the thing that's a little bit strange. He was trying to push to see how far this mechanical view of nature works, but his critics claimed that with his universal law of gravity, and we'll talk more about this later, but with his universal law of gravity, he is really bringing back into natural philosophy occult or hidden quantities. After all, the force of gravity is an invisible force that acts between the sun and the moon. And when you have one object that is pulling on another object without touching it, I mean, that's about as close to magic as you can get. That's really strange. And Newton was advocating for this kind of law of gravity that was mysterious or occult. So that's the kind of thing that Newton, although he was trying to take the mechanical picture very seriously, he ended up doing the exact opposite in a sense. He showed that there are, in fact, these sort of occult or hidden causes in nature that are very difficult to understand. Okay, and so that finishes my discussion of Newton's preface to his Principia. Let's, in the next lecture, jump right into talking about Newton's definitions.